Hello, this is Ajinkya Vaksavare, Assistant Professor, Department of Physics, Dr. Babasaheb Ambedkar, Technological University, Lonere. This is the third video regarding electron optics. In this video, I am going to explain the concept of motion of an electron in a perpendicular electric field. Consider an electron that is moving along the x-axis. Consider the two metal plates. The one metal plate is positively charged and second metal plate is negatively charged with the help of the batteries. The electric field developed between these two plates is vertically downward and shown by the letter capital E. Now consider the electron is just entered into the electric field. As soon as electron enters into the electric field exerts a force on that electron and the force will be vertically upward. And this force is given as F is equals to E into capital E. Here, small e stands for the charge of an electron and capital E stands for the electric field. So by using the Newton's second law, we can find out the acceleration, and the acceleration will be equal to E into capital E divided by m. Here m is the mass of an electron. So due to this electric force, electron changes its path and electron follows a parabolic path, something like this. So when electron enters into a perpendicular electric field, the path of an electron will be parabolic one. So the path of an electron is parabolic path, something like this. Now let us discuss the mathematics behind this particular motion. So for this, consider the two metal plates. The first one is positively charged, second one is again negatively charged. The separation between the plates is small d and the electric field between the plates is vertically downward, shown by the letter E. Consider an electron that is just entered into the electric field. Before entering to the field, electron was moving along the x-axis and the vertical axis is the y-axis. So electron will follow a parabolic path, something like this. The angle between the tangent and the horizontal x-axis is theta. Now, the vertical displacement of an electron is denoted by the small y. Before entering into the field, the y velocity of the electron is 0, that is uy is equal to 0. As there is no force acting on the electron along the x-axis, so the acceleration along the x-axis will be 0. So the velocity along the x-axis will remain constant. So ux will remain constant. And the final velocity of an electron along the y-axis is vy. So the x velocity of an electron will remain same and the y velocity of electron will change. So basically, in this case, the electron possesses two kinds of motions. One is horizontal one and the second one is vertical one. So it is the combination of horizontal motion and the vertical motion. So let us discuss the mathematics. So acceleration along the x-axis is 0. Keep this in mind. So the velocity along x will remain constant. Only the y velocity will change. Also keep this in mind. The initial y velocity, that is uy, is 0. So acceleration along the y direction is given as ay is equals to ee upon m. Now let us calculate the velocity attained by an electron after traveling a time small d in the electric field. That means we are going to calculate the y velocity. So the y velocity will be calculated by using the kinematical equation. So use the kinematical equation, that is vy is equals to uy plus ayt. Here uy is equals to 0. So our equation becomes only ayt. and they put the value of ay, it yields E into capital E into T divided by M. Now, let small y is the displacement of the electron, and let us calculate this displacement. We can calculate the vertical displacement of an electron by using the kinematical equation again. So use the kinematical equation, that is y is equals to uyt plus 1 half ayt square. Again, uy is equal to 0. So equation is simply y is equals to 1 by 2 ayt square. Now put the value of ay, we will have y is equals to 1 by 2 e into e upon m into t square. This is the equation number 1. Now the horizontal velocity of an electron will remain constant. Why? Because the force along the x-axis is 0, so the acceleration is 0. So there will be no change in the x velocity. So the horizontal displacement of an electron is given as x is equals to ux into t. Now put the value of t in equation 1. So basically calculate the value of t from this equation. So it would be t is equal to x upon ux. So put the value of t calculated by using this equation in equation 1. So we get y is equals to 1 by 2 e into e divided by m ux square into x square. Here 1 by 2 small e, capital E, small m and ux are constants. So the quantity in the parenthesis is constant. Only x, capital X, is the variable that is going to change. So instead of parenthesis, we are going to use the constant k. So it gives me y is equal to kx square. And now this equation, that is y is equal to k into x square, is the equation of parabola. So from this, it is clear that the motion of an electron or the path of an electron when it is moving through a perpendicular electric field will be a parabolic one. Thank you.